So for those of you who couldn't wait or think you figured it out, let's think our way through it. We've got an inductor where the current is flowing, and you know that it can't go anywhere because it's not really allowed out, right? It's not a closed circuit. But the inductor must push the current forward, so it does. It'll push this current over here until it kind of bottlenecks over on one side. And that'll also rip more positives out of the other side, and you'll have a little bit of a charge imbalance on the two sides. Obviously, that's not tenable, right? And this is going to drop to zero quickly when it's shoving up against this brick wall, I guess. So when the current stops, now I've got two charges that are separated. Well, they want to meet each other. So this starts to try to rush back through. That energizes the inductor, and the inductor says no, continue flowing. And you see an oscillation that's running back and forth through this system. You built an LC oscillator. What's the area of the capacitor plates over here? Better yet, let's just take this inductor and kind of wrap the wires around. So if this is my inductor, I'll turn these around and maybe put the two edges kind of like that. There is an area at the edges of these wires, right? If it's useful, we can talk about them like that, but the area is almost zero. So what's that mean? For the capacitor, I've got epsilon naught A over D. If this is almost zero, this is a tiny, tiny, tiny capacitor. Okay. Well, what do we know about this? What would the resonance frequency or the natural frequency of this oscillator be? If this capacitor is almost zero and it's in the denominator, then this is really close to infinity. So all of this magnetic field energy that's stuck in here and the current that's flowing, the instant I rip this out of the circuit, it's still going to flow. And it'll go dong, and it'll ring itself down, and every time it flies through here at near infinity, super high frequency, every time it does that, it heats up a little bit and bleeds all that field energy out. So it is possible. You can suddenly snap this thing out, and even though, it seems like there's a paradox, there is a reasonable solution.